Solve for all solutions. Solve for all solutions means I want what? What at the end? Yeah, the general term, the general solution at the end. That's what I want. So you solve it like it's between 0 and 360 or 0 and 2 pi. Always. Doesn't matter. I don't care. I never look at the restricted domain until I've solved my standard. 0 to 360 or 0 to 2 pi. Then I'll look at the restricted domain. But I do not do that until I've actually gotten those. Because it's really easy if you just do the 0 to 360 first with the 0 to 2 pi. I'm going to do 0 to 2 pi because they want it in radians. Eventually this will keep up. Okay. So, first thing I'm going to have to do here is add the 1. So I get root 2 sine x equals 1. This sine x needs to stay. Some of you guys drop the x's off. Make sure not to do that. How do I get sine x by itself? Divide by root 2. What is 1 over root 2, just the unrationalized version of? Root 2 over 2. That's all it is. So, I don't care that it says general term. I'm going to ignore that for now because that might be overwhelming to me. So I'm going to completely ignore that. What I'm going to do is I am going to find the spots between 0 and 2 pi where that happens.
45.
Yeah. And it's sign positive, correct? So that's going to be on the top 2 quadrants because sine is y and y is positive up here. So it's going to be at 45, which is actually, yeah, pi over 4. And then this one is
3 pi over 4.
3 pi over 4. So those are 2 perfect answers. They weren't hard to find, were they? They're just the ones from 0 to 2 pi. That's what we always find every single time. Then we go from there about what the heck the domain is. So now I'm going to be like, okay, I'm going to go look at what the domain is, even though I already looked. I sometimes squint because I don't want to really find out. So I find out, and it says general solution. This should make you happy. These are really easy to do as general solutions. Because you have 2 solutions here, you can just do both of them separately. This one's at pi over 4, correct? So I'm going to go and look at my variable. I'm not going to write a theta. I'm going to look and see, oh, the variable is x. Okay. So x equals pi over 4 is my first solution. Plus how long does it take to get me back there? Plus 2 pi. And then what do I have to put? N. And then n is an element of the integers. Boom. Done 1 solution. Wasn't too tough. Have I done all the solutions though? No, I'm just done 1. How do I do the second one? What is the next one? 3 pi over 4. And what do I have to do to get to it? Add 2 pi or subtract 2 pi, either way, right? But how I show that it's a general solution is add 2 pi n e pi. Done. That's it. That's all it is. And if this is a written response on the diploma or on my unit test, you can always just take every solution and add 2 pi to it. You don't even have to try and put them together. You can just list 2 pi n e I. There was no difference in marking for the people who wrote them separately or the people who tried to put them together. These ones you can't put together, but tans you can because they're 180 apart. So you could technically work them together by 180s. But if you have 2 solutions, you could literally just write 2 pi n after every single one. Unless it's a multiple choice, we have to make them match. Okay, you guys are trying the other one. Oops, I'm going to cut into that 4. You try B. So, we're going to go 2 cos squared x equals 1. Divide by 2. You get cos squared x equals 1/2. And then you have to take the square root. And whenever you take the square root, it's plus or minus. And remember I said to you guys that you can split the square root up if there's a perfect square somewhere. And the square root of 1 is 1. And the square root of 2 is just square root of 2. And remember, what is this just? The unrationalized form of? Root 2 over 2. So when you take the square root, please remember the plus or minus sign or you will get 2 out of 4 answers every single time you'd be wrong. And they will have 2 out of 4 answers there in your multiple choice and you'll pick it and you'll be all happy, but you should be all sad and you don't know it. Saddest to him. So, because we need the 2 spots where cos is positive root 2 over 2 and the 2 spots where cos is negative root 2 over 2. Well, where are the 2 spots where cos is positive?
7 pi, 7 pi fourths.
7 pi over 4 and
And
pi over
pi
4.
fourths.
And then where are the two spots where cos is negative root 2 over 2? 3 pi over 4 and 5 pi over 4, yeah. Now, if this was a written response question, no joke, you could go x equals pi over 4 plus 2 pi n nei, x equals 3 pi over 4 plus 2 pi n nei, x equals 5 pi over 4 plus 2 pi n nei, x equals 7 pi over 4 plus 2 pi n nei, and you won't lose any marks. You've just given 4 solutions, a lot of them. You could do that. Every single one separately. You will not lose marks. Yeah?
Yes.
So we could split it into 2 solutions if we wanted to. We could go pi over 4 plus pi n nei and 3 pi over 4 plus pi n nei, because it would land on all of them. Or because these are happening every 45, they're how far away from each other? They're 90 degrees, which is what in radians?
1/2 pi.
1/2 pi, or pi over 2. So these babies are happening every 90 or every pi over 2. Just this particular instance. It's the hardest part about general solutions when you're trying to put them together, because they don't always follow suit, right? Each one of these are pi over 2 away from each other, are they not? So I could literally state all 4 separately and you will not lose marks. I promise you, I've witnessed it. Okay? But if this is a multiple choice, they won't list all 4. They'll list the simplest version, which is pi over 4, or pi fourths, plus pi over 2n nei. Okay? But if it's a written response and you list every single one of them, we were like, then why wouldn't everyone just list every single one separately? Because then you won't ever make a mistake. And they're like, yes, I agree. And I was like, okay. Going home with that knowledge. So that's the knowledge I have for you. Because some people, when they put them together, actually messed up, right? They'd put them together wrong, but they had all the solutions right. It was just sad to stay. I don't remember how much you lost, but sad. Okay, example 2, we're going to look at this one. What is up with example 2? Yo, what's that?
So, on like a short answer, if you put just one, would it be right or wrong?
If you put one, you'd only cover one of them. Or are you meaning the one that we've boxed?
Well, like if it's a short answer and you just put one, because like on the multiple choice, but I guess.
So if it's a short answer and you do pi over 4 plus pi over 2 n nei, you're perfectly fine because you covered them all. But if you just went pi over 4 n or pi over 4 plus 2 pi n nei, you've literally just covered all these coterminals that only go with pi over 4. You've literally only covered this one solution. So then you'd have to go 3 pi over 4 plus 2 pi n to cover all the arms, all the ones that land on there, and then 5 pi over 4 plus 2 pi n to land on there, and 7 pi over 4 plus 2 pi n. So every single answer you have between 0 and 2 pi, you have to write a coterminal with it. Or you're not covering every single one of those coterminal angles. So we covered it by writing it as 1, but if we wanted to, we could pick every single answer that always exists between 0 and 2 pi and write plus 2 pi n nei, or plus 360 n nei, but we have to list every single one that way, which is fun. Okay, this one here says solve secant x and then 2 cos x minus root 2 equals 0. This is actually nicer than its friend. That could have been written like this. So this is actually GCF'd out already, isn't it? This question could have been written as 2 secant x cos x minus root 2 secant x. This question could have been written like this. And what would you have to spot that you could do to both of these? Take out a secant. And more often than not, it's written like this, where a GCF has to be taken out. Then it's already nicely taken out. So I can take a secant out of both of these. And then I'm left with 2 cos x in the first term, minus, and then a root 2 in the second term, equals 0. So that's just the way we started it. But do you see how it could have been written like this first, and then you'd have to do this step to get there? Yeah. More often than not, it's written like this first. So once you've taken the GCF out, this one can go in its own bracket. It has a secant by itself. This is 2 cos x minus root 2 all by itself. So when you have two factors by themselves, you can take them each and set them equal to 0. That's what you learned last year in quadratics. Once you have two factors, you can set them equal to 0. So this one would be secant x equals 0, and this one would be 2 cos x minus root 2 equals 0. Now all I'm going to do is look above to see if it's in radians or degrees. I'm not going to see if it's a restricted domain. I'm not going to see if it's any of that. I just want to find the answers between 0 and 360 or 0 and 2 pi. So it wants the value of x in degrees. So I'm going to go find the answers that fall in 0 to 360. That's it. Okay? Secant x is not helpful, but its friend is. So secant is r over x, correct? So this would technically be over what if it didn't have a number? 1. Right? Now, we can think of it as secant x equals 0 over 1. So what would cos x equal? 1 over 0. Does that happen?
Yeah.
So try this out. Can I show you something? So before we go to do this question, we are always going to type them into our calculator to know where we're going. Okay? So go right to your y equals, and we're going to type in this equation. So we type into y1, we're going to type in this left side. Secant x, I'm just going to show you, we don't have the button, but I'll show you what we're going to do. Secant x equals 2 cos x minus root 2. That's going to go into our y1, our left side, and into our y2 is going to be our right side, which is 0. The only problem is, how the heck do I type secant in? 1 divided by cos. And if we forget, our formula sheet tells us how to type it in. On our formula sheet, it says secant is 1 divided by cos, correct? So if we don't know how to type it in, our formula sheet tells us. So we're actually going to type y1 in as 1 divided by cos x, bracket 2 cos x minus root 2. And I'm always going to put it in degree mode for my own welfare for this one. So I'm going to go mode, degree. And then I would go zoom trig to get it to show up. So everyone should be typing it in. So in y1, you're going to have 1 divided by cos x, bracket 2 cos x minus root 2. Close bracket. Then I said I would go mode, degree, and then I would press zoom trig, because you only want to press zoom trig after you pick the mode, because it puts it in whatever mode it's in, right? So then I go zoom trig. And it's going to look wonky. It's going to look like parabola down, a parabola up, a parabola down, a parabola up, a parabola down. Do we agree? Do you have that sitting in front of you? And in your y2 you have 0. So it's going to look like this. Down. So your y2, I would make it thicker, just so you know. So you're going to have bracket 1 divided by cos x, bracket, bracket, bracket 2 cos x minus square root 2, bracket, oops, gotta close, arrow out, then bracket. Then I went mode, degree. I'm not in degree, so I'm going to go to degree. Oh my gosh, really? Degree. And then zoom trig, which is 7. So you get something that looks like that. And then I'm going to have a red line along my x-axis because I'm going to go to y2 and I'm going to put in a 0. See that? Everyone sees that? Now I want to find the answers between 0 and 2 pi. Because I want, or 0 and 360, sorry, because I want just the standard angles. So I'm going to go to my window, and I'm going to make my x min be 0, and my x max be 360. So that I'm just seeing those standard coordinates. Do you agree? 0 and 360. It doesn't matter. You can leave it at 90, you can put it at 45, it doesn't matter. Between 0 and 360, how many answers am I going to have? How many times does it cross? Twice. That's it. I'm going to have 2 solutions. What are they going to be? I'm literally finding all this out before I even do any math. Let's find out what they are. So you might want to make your Y2, that 0, thicker so that you can actually see it. I can see it because it's colored, right? But your Y2, remember, you can arrow over to the slash line. You can arrow over on this Y2 to this slash line and hit it once, and it makes it thicker. Remember that? So then I have this graph. So I can go second, trace, intersect, pop down onto that red one, move my cursor over here, and I get enter, enter, enter. So 45 is one of my answers. Then I go second, trace, 5, pop onto the red. This is taking, it's fighting me. Move all the way over. This is crazy. Like I'm at 44 arrows. Stupid. It's aggressive. Enter, enter, enter. 315. There's my 2 solutions I should have. So when I solve this, I should have 45 and 315 as my 2 solutions. Now, this is a multiple choice. Could I just go like that? Boom, boom, done? Not even use a calculator, right? So that's why often these are put on a written response on a diploma, because they're not a technology outcome for the most part. They're an actual solve algebraically outcome. But does it hurt that I used my calculator to know where I'm going? No, it's helpful. So I know that in the end, when I go to solve this, I know I'm going to have the variables x equals 45 and 315 are going to be my 2 answers that fall between 0 and 360. I know that knowledgeably off to the side, correct? And when you know that, knowledge gives you power. So when you see this cos is undefined, and you're like, cos isn't undefined anywhere, it's a continuous graph, you're okay with saying no solution. This creates no solution. There are no points where it's undefined, because this is undefined, correct? Undefined means asymptote. Is there any asymptotes on a cos graph? No, cos graph starts at 0, 1, and it just, and then it goes this way. There's no solution when you get cos x is undefined. And that makes me feel okay, because I know 45 and 315 is coming from this one. So the moment I found the 2 answers, I know they're 45 and 315. I know they're going to come from here. That made me feel okay about this one being wonky and no solution. So let's solve this one out. We're going to get 2 cos x equals root 2 by adding it over. And then we're going to divide by 2. So it's cos x equals root 2 over 2. Where does that happen? Shockingly. 45 and 315. And do I feel a lot better about this question at this point? I feel a lot better about myself. I'm like, okay, I'm not completely out to lunch. That is wonky, and it's okay to be wonky. I'm not getting a solution from it. There wasn't one, right? They just fit the other one, so you feel better about yourself. Now, it wants it for all values of x. So, what does it want? General solution. So we're going to go x equals 45. Can I put these together? If you put them together, then it won't work, right? Because they're not directly. The only way you can put them together is if they're like directly across from each other. So this one and this one I can't. They're side by side. So it's going to be 45 plus 360 degrees n NEI. And x equals 315 plus 360 degrees n NEI. And the only other thing here is state non-permissible values. What's my only issue on this one? Which is the only thing on there in that equation that will get me a denominator? Secant will get me a denominator, won't it? This up here, cos, that's fine, it's secant. Secant up there is the same as 1 over cos. So what's in my denominator? Cos x. So I have to state all the places where cos x can't equal 0, because there it's in the denominator, right? So my MPVs come from this. Where does cos x equal 0? Cos is x. Where does x equal 0? So I can just write that as a general solution, can't I? So I know that that's my solutions, that's great. But I know x also can't equal 90 plus, these are directly across from each other so I can lump them together, right? 90 plus 180 degrees n NEI. That's my NPVs. And on a diploma, this could be a question out of 5. You have 3 questions out of 5, 1 bullet worth 3 marks, 1 bullet worth 2. The solving this would be the bullet worth 3, and the non-permissible values would be the bullet worth 2. And the reason why this particular one could be asked together is because your non-permissible values are not dependent on the actual question itself, right? Like if you mess up your solutions, does it affect your non-permissible values? No, these are completely separate. Each bullet in your diploma on each question, there's 2 bullets, they have to be not like reliant on each other. So like you can make a mistake in the first bullet and it can't affect the second one, or they won't ask it that way. Okay? They have to be separate from each other. Okay, let's flip over. All right. This one gets done terribly badly all the time, but it's actually a really easy question if you remember the first step. So what people try and do here is they try and divide the cos x over. Remember when you have a squared, so quadratics was one of the biggest things brought to you in 20-1, and then you brought like 800 other functions in grade 12. But in grade 11, quadratics and absolutes. Thank you, grade 11. So with quadratics, what was the rule in order to solve a quadratic? You have to get one side equal to 0, correct? So is that a quadratic? Cos x squared minus cos x? It could be. Let's replace it so that you see that it actually is. Let's replace the cos x's with m's. Then you won't make mistakes as much. So I'm going to go let m equal cos x. If people make these m's, they make way less mistakes. So I'm going to replace my cos x's with m's. So I'm going to get m squared equals m. Right? So that is a quadratic. What would we do in grade 11 when we got this? Move everything to one side, set equal to 0. Move everything to one side, set equal to 0. That was what was drilled into your heads every single time, right? So what do I have to do? I have to subtract the m. Do you know how many people divide by m? Almost everyone. It's really bad. You get rid of half of your solutions if you do that. So this is a quadratic. Your rule when something is a quadratic is move everything to one side, set equal to 0. So my first step always is going to be to subtract the m over. So I'm actually going to get m squared minus m equals 0 because this is a quadratic and that was drilled into your heads in grade 11 over and over and over. Move everything to one side, set equal to 0. Now what could I do? I can't factor it like in a trinomial factor because it's not a trinomial. This is actually one of the easiest questions. Done the worst. You're getting, I know what you're saying. GCF out. Yeah. Take out a GCF of what? M. If you take an m out and you're left with m minus 1. And then in grade 11, what was your next step you were taught? Set them both equal to 0. Nothing crazy. This is just grade 11. Because I'm not even touching the cos right now, am I? This is all grade 11. So I'm going to get m equals 0. That one's done. This one's going to be m minus 1 equals 0. Add my 1 over. M equals 1. Now if it was grade 11, I would box those babies and move on. But it's not grade 11, it's grade 12, and we didn't actually have an m in this question. So what do we have to do? Change it to coses. You know, people stop here and box it and they're just so happy. And I'm like, but we didn't even have an m. So go back, put in your cos. So we have cos x equals 0. We need to find the solutions for that. And then we have cos x equals 1. And we need to find the solutions for that. That's it. That's all. It's nothing crazy. Nothing crazy at all. Now, I go and look at my domain. I don't care if it's restricted or not. I just go and look at it to find out if I'm working in radians or if I'm working in degrees. What am I working in? Degrees. So I'm going to find the solutions for cos x equal to 0 that fall in 0 to 360. Where do they fall? Where is cos x equal to 0?
90 plus 180 and...
So we're just going to put the solutions, whatever they are. Not the general, just what they are. So this is 90, and this is 270. Boom. Once I get those answers, I go look and see, does it fit in my restricted domain? What is my restricted domain? 0 equal to, so equal to 0, and then all the way to 360, but not equal to 360, correct? Do these fall in there? Yeah, done. Done for these ones. X equals 90 and 270. Let's do the other one. Cos x equals 1. Where is cos x equal to 1? At 0 and at 360. So those are the ones that fall between 0 and 360, which we always state first. And then we go to our domain. And Canyon, you said? 360 isn't included because it's a round bracket, so we just chop it off, right? And so then x is going to equal 0. And then our last step is to just write them all out. X equals 0, 90, 270. Okay, I'm trying this out in my calculator. Type that in. This is all you have to do. Remember, what's in y1 is on the left, what's in y2 is on the right. Don't move anything. This is y1, this is y2. How the heck do I type this in, though? Because the square doesn't jump in front of it. Like, there's no, you can't get a square to pop in here. The moment I press cos, a bracket opens up. Yeah.
You just like put brackets around the cos.
Yeah, you just put brackets around it. So my y1 is actually going to be cos x all squared. That's how you have to type it into your calculator. And then my y2 is cos x. So type those in. y1 is cos x all squared. And then y2 is cos x. What mode do I need to be in? Degree. Can I go zoom trig? Sure. But what do I need to restrict my domain to be? 0 to 360. Why? This one is restricted to 0 to 360. So you might as well make it be what it's restricted to. Then your answer should match, right? You should get the exact same ones. So I'm going to go bracket cos x, bracket, squared. And then here I have cos x. And then my window's from 0 to 360, it already is. And I press graph. Where am I looking for solutions? I know where I'm looking for them. I have them. I'm hoping that there's one at 0. I hope there's one at 90, and I hope there's one at 270. Will 360 show up on here? Yeah, because I gave it 360, but I just can't include it. Correct? So let's see. I'm hoping at 0 I got one, because I have one at 0. If not, ugh. Okay, so I'm going to go second, trace, 5, and I hope at 0 that these babies are crossing. I hate this calculator. It takes too... Oh, it's speeding up. I gave it crap, and it sped up. Oh my gosh. I think your guys' is bad. Okay. Enter, enter, enter. Why is there no sign change? Maybe 0 isn't included in this because I made it, suckered up to it too close, right? So what I could do... I know I'm looking for 0, so I'm going to go -5 just so I have a little bit of room to do my crossing. So I'm going to go second, trace, 5. Sadly, I'm going to have to do this again. There you go, enter, enter, enter. Okay, what is e to the -5? Yeah, that's just 0 decimal, 4 zeros, 1, 7. Like, whenever you see e to the negative anything on your calculator, that is 0. So look for it. When you see e to the negative something, that's 0. Correct? So when I'm finding the intersections, do I actually care what the y is? Nope, I only care what the x's are. So what's the x in this one? It's 0, right? Because e to the negative something is just 0. Okay, I got one answer, yay. Second, trace 5, I'm hoping for the other ones. I feel confident, because they look like they're crossing at 90, which is my scale. Why? Aggressive. Enter, enter, enter. 90, woohoo! Second trace 5. Let's go to the next one. Come on. Enter, enter, enter. 270. Aha! And if I move the 360 over, it's going to give me 360, but I can't include 360 because it's not a square bracket on the restricted domain. And now I feel like I'm $100. I got myself a good question. I got my answers right. I'm happy. Okay? You can use your calculator every single time to check them. All right. And then chapter 6. So all of that was mainly from chapter 4. Here's the chapter 6. Okay. I have myself a squared. So when I have a squared, I always have to do what? Nope. Move everything to one side, set it equal to 0. The only time I don't do that is here. When we go back here, do you see this one? It had just a squared with a number. Then I can move it over and take the square root of it, correct? But if it's a squared with a variable, you can't do that. You have to move it, set it equal to 0. So I have this co-squared sitting here. I need to jolt it over. So I'm going to go sine squared x minus sine x plus 1 minus cos squared x equals 0. If I can't take a GCF out and fix my problems, I have to go to my formula sheet. Can I take a GCF out and fix my problems? Can I take a cos squared out of everything and then my problem would be fixed? No. So then I need to go to the formula sheet. Now, I could swap out sine squared x or I could swap out cos squared x. This is how you know which one to swap. What's my single one? My single one is a sine. So I have to switch everything to sines. So whatever your single one is, you need to make everything else be it. So I'm not going to swap the sine squared. I'm going to swap the cos squared. So I'm going to put this in brackets. I need to swap the cos squared, not negative cos squared. I just want to swap the cos squared. So I rewrite the rest the same. Sine squared x minus sine x plus 1 minus, and then I need to swap my cos squared with something. Where do I go to swap my cos squared? With something that hopefully is a sine.
1 minus sine squared?
Yeah, we just use the Pythagorean theorem identity. Often for these trig ones, it's the Pythagorean theorem ones that fix your problems. So I'm going to look here at sine squared x plus cos squared x equals 1. Off to the side, I'm going to show it to you. So that's what we're going to be looking for. And I want to swap out cos, so I'm going to move that over. So I'm going to go cos squared theta equals 1 minus sine squared. So do you see how I'm replacing only the cos squared? Do you see that minus sign sits up front? And whatever I replace puts in brackets. So you always do, whenever you substitute something in, it should go in brackets. So I'm going to take this cos squared x, I'm going to toss it behind my head, I'm going to replace it with 1 minus sine squared. I'll write it in black just so you can see it's different.
And the 1 cancel.
Slow your roll. Okay. So what do we do with the minus in front? Distribute it. That's why I have to put those brackets, right? So we're going to get sine squared x minus sine x plus 1 minus 1 minus a minus sine squared is actually plus 2 sine squared x equals 0. Now what can I do? Collect like terms. The 1 and the negative 1 cancel. So I just get 1 sine squared x plus 2 sine squared x's is how many sine squared x's? 1 plus 2 is 3 sine squared x's. And then minus sine x. And then it equals 0.
Where'd you get the 2's? How did you get 2 sine squared x?
I don't know. I was thinking of putting them together already. A little early.
Yeah, isn't it just like 2 sine squared x?
Yeah. I don't know what I was doing. I really wanted to put a 2 in there. I think that's the cos formula. Cos 2x formula. It's 1 minus 2 sine squared x, I believe. Nonetheless, it was wrong. Okay, so what do we have to do here?
Change it to m.
Sure. Let m equal sine x. So we have 2m squared minus m equals 0. You have to do a let statement. This is real math. You can't just go m. Make it m's without saying that m is sine x. Now what can I do? Yeah.
I just have a question.
Yeah.
Could you do this question by changing the 1 minus cos squared x into sine squared
Yep.
x?
Absolutely. There's varying levels. You could also go just and change the negative cos squared x out. You know what I mean? Like there's all options. Yeah. So you could have taken the 1 minus cos squared x, completely thrown it out and replaced it with sine. Absolutely. What can we do here? Take out an m. So we're going to take an m out and we're going to get 2m minus 1. And what do I do?
Will equal to 0.
Yeah. So I get m equals 0. 2m minus 1 equals 0. 2m equals 1. Divide by 2. M equals a half. And what's m? Sine x. Sine x equals 0. Sine x equals a half. Grab the answers for it. It wants it in radians, right? So I'm going to get my 0 to 2 pi in radians, even though it is restricted to that. That's fine. But I would still do 0 to 2 pi anyways. All right. So where does sine equal 0? At 0. Ooh. Yeah, 4 answers. 0, pi, and 2 pi. What's my problem? 0 is included. 2 pi is round bracket. Do you see that? So 0 gets to stay, pi gets to stay, 2 pi, gonzo Alfonso. Then, where is y equal to a half? A positive a half. Right here and right here, which is pi over 6 and 5 pi over 6. We agree? Do both of those fit between 0 and 2 pi? Yes. So theta, it's not a theta, it's an x, you dummy. X equals 0, pi over 6, 5 pi over 6. You're going to flip over and do example 5. Example 5. Remember, we can check these with our calculator, couldn't we? We could see that these match. We could do these in radians. How could we match them, though? Turn these into decimals and match them, correct? Because on your calculator in radians, you're going to get them in decimals on the screen. But you can turn those into decimals and match them. All right, you're on example 5. What is our issue? Does not equal 0. That's our first issue. So we're going to get 2 cos squared x minus 3 sine x equals 0. Our next issue, we always check, can I take a GCF and fix my issues? No. If I can't take out a GCF and fix my issues, I have to go to my formula sheet to fix my issues. Remember, the single ones can never change. The degree ones, the ones with an x, just a plain old x, can never change. So this baby's staying. Well, it could change. You could change it to 1 over cosecant. That just sounds really awful. So please don't. Okay? Don't go that route. So which one are we going to change? The 2 cos squared x. Now, do we have to change the 2? No, we can leave that bad boy sit out in front and just change the cos squared x, correct? Just when we do it, we have to substitute in brackets. So we have to remember to distribute, because this is done always wrong, not because people don't know to just, first off, people will just say, oh, she must have meant to write sine squared, and you will change me out. Do not do that on a test. I have had people literally on my written response cross the cos squared off with it and put a sign. They're like, she must have forgot. These two can't go together. Bad. I'm just like, oh boy. Oh boy. No. I didn't forget. I didn't make a mistake. That was intentional. So the 2, the co-squared can get changed. Our formula is co-squared x plus sine squared x equals 1. And I need to replace with co-squared, so I'm going to get co-squared x equals 1 minus sine squared x, right? People will sit here for life, too, and be like, there's nothing to replace the 2 we don't need to replace the 2. The 2 isn't our issue. It's the co-squared that's our issue, correct? So we're going to replace the co-squared with 1 minus sine squared x minus 3 sine x equals 0. Then what must I do? Distribute that 2 in. 2 times 1 is 2. 2 times negative sine squared x is negative 2 sine squared x minus 3 sine x equals 0. Now it's actually a really nice trinomial. It just looks ugly because it's not in order, right? So negative 2 sine squared x minus 3 sine x plus 2 equals 0. It's equal to 0. We're happy. It's all sine squareds and sines. We're happy. We can replace the signs with m's and factor. Go try it out. With this one, you could have went y1, y2, and checked from 0 to 360 what you get, right? You can check these every single time. Will you agree? 0 to 360, 0 to 2 pi. All right. So here I would go, let m equal sine x. So I get negative 2m squared minus 3m plus 2 equals 0. And I say what times what equals negative 4. Front times last. What plus what equals negative 3. And it's going to be negative 4 and 1. So we have to replace our middle term with that. So we get negative 2m squared minus 4m plus 1m plus 2 equals 0. Group. Take out a negative 2m, and I'm left with m plus 2. Take out a plus 1, because I can't take anything out. M plus 2. And so I get negative 2m plus 1 and m plus 2. This one here, you get negative 2m plus 1 equals 0. Negative 2m equals negative 1. Then m equals a half. This one is m equals negative 2, and you don't know it yet, but this one you should throw a little party for. Because this one don't get you any solutions. When you're sine x, cos x, whatever, if it's sine x or cos x, if it's above equal to 1 or below equal to negative 1, it don't intersect. Your circle like rotates around 1, and then there's some floaty crap up here down here. Ain't gonna, like there's going to be no crossing points. So this one here, sine x equals a half, I'll do those in a second. This one, sine x equals negative 2. If you don't believe me, the sine x graph goes like this. And it maxes out at 1, and it mins out at negative 1. And then there's a lovely graph being drawn down here at y equals negative 2. Remember, this would be your y1. This would technically be your y2. Are they ever crossing? No. So if you have sine x or cos x, and it's less than negative 1, just sine x by itself, or cos x by itself, and it's less than negative 1 or it's greater than 2, this gets you no solution, which is why you're super happy, because you don't have to do any work. You just have to spot that gets you no solution. Because there's no places where sine x can equal negative 2 when it's minning out at negative 1, right? Sine x mins out at negative 1 and it maxes out at 1. There's no way that sine x can equal negative 2. Negative 2 is down here, and the graph is going like this. Up to 1, down to negative 1, up to 1, down to negative 1. There's no places where sine x can equal negative 2. None. So if your sine x or cos x, only sine and cos, are greater than 1, equal to greater than 1, or equal to less than negative 1, you will get no solution every single time. But only sine and cos. Don't like say tan does that. Tan graphs go on for life, right? They'll cross. It's just sine and cos is because they max out at 1 and negative 1, and at negative 1. Where does sine x equal a half? Here and here. Seems like this solution has happened 8,000 times. So this is 30 and 150. So we're going to go x. Is it x? Yeah. X equals 30 degrees plus 360 degrees n, NEI. Or you could have done it in radians because it didn't specify. Pi over 6 plus 2 pi n NEI would be the same thing. And then this one is 150 plus 360 degrees n NEI. Or you could have given the radian measure, which is 5 pi over 6 plus 2 pi n NEI. Your homework, which I'll start typing in the homework column, is page 320. Numbers 1, 3, and then 4 and 6. I could try and cut it down, but you get better by practicing. It's the only way these happen. I'm sorry, that's how it works. It still ends up being around 10 questions because 1 and 3 have 4 questions per each, but they're 0 to 2 pi, both of them. If you're someone who's like, I need more practice, well, looky here, there are more questions. You can choose more. You can't be like, wow, she gave us no more, we can't do any more. Yeah. Yeah. So tomorrow, your assignment is going to be this. I'm just going to explain it to you. It's 6.1 to 6.3, so it's not including this stuff, it's including everything but that. So if you look at, I'm recording it, I know I'm recording.